The end of the 1980s. The Soviet Union is bursting at the seams, but in Kharkov, a group of designers is working on a project that was supposed to bury all Western tank developments. A machine with characteristics that sound like the ravens of a science fiction film. Protection against which any NATO shells are powerless, firepower capable of turning an Abrams into a pile of scrap metal with the first shot, and a layout so insane that even experienced tankers twirled a finger at their temple. The project was led by the son of the legendary Alexander Morozov, the man who created the T-34. Eugene Morozov set himself the task of creating a tank where the crew would survive any hit. But to do this, he had to break all the rules of tank building. And in the end, a monster was created that the world had never seen. The 1980s were a time when Soviet tank building had hit a concrete wall. 3 main battle tanks were in service: the T-64, the T-72, and the T-80. They were all relatively cheap, mass-produced, and technological. They all had a classic layout: the mechanic driver in front, a turret with 2 tankers in the middle, and the engine in the back. And they all had one critical problem that the military did not like to discuss out loud. The crew had practically no chance of surviving if the armor was penetrated. The reason was simple and terrible at the same time. In Soviet tanks, everything was in one cramped space. 3 people, an ammunition load of 40 shells, fuel tanks, the engine. The designers squeezed out every centimeter, creating compact, low-profile machines. This gave an advantage. The tank was harder to detect, harder to hit. But when a shell pierced the armor, it met not empty space but a densely packed compartment where shells lay next to people and fuel splashed. The result was predictable. The detonation of the ammunition turned the tank into a mass grave in a fraction of a second. Western designers also knew about this problem. The American Abrams M1, the British Challenger, the German Leopard 2. They were all much larger than Soviet tanks. In them, the crew was placed in an isolated compartment. Ammunition was stored in a special niche of the turret with blowout panels. Upon detonation, the blast wave went not inward, but outward. The tankers lost the machine, but remained alive. Soviet tankers did not have such luxury, and the Swedes generally went their own way and created the turretless STRV-103, a tank destroyer with a fixed gun, where crew survival was ensured by a low silhouette and sloped armor. But Soviet generals needed a full-fledged tank, not a compromise. By the mid-80s, this had become a critical problem. NATO anti-tank weapons were becoming more and more powerful. New shaped charge shells, guided missiles, sub-caliber ammunition with uranium cores. All this pierced Soviet armor at distances of 2 to 3 kilometers. One could increase the thickness of the armor, install dynamic protection, improve sights, but the fundamental problem remained. If the shell penetrates, the crew is dead. At the Kharkov Morozov Machine Building Design Bureau, they understood this better than anyone else. It was here that the legendary T-34 was once born. It was here that they created the revolutionary T-64 with composite armor. And it was here, in the late 70s, that work began on a tank that was supposed to solve the survival problem radically. Eugene followed in his father's footsteps and now faced a task no less ambitious: to create a tank of the future, where Soviet tankers would get the same chances of survival as their NATO opponents, only without increasing the size of the machine by 1.5 times, as the Americans did. On the designer's table lay several variants of the prospective tank. Object 490, under the general code Topol. Object 490A with the code name Buntar, and one more project that few knew about even inside the Design Bureau. A project so radical that its details were classified even from the majority of the Bureau's employees. 3 chances to create the tank of the future. But it is worth starting with the very first one, with Topol, because it was with it that this insane story began. Object 490. Topol was the brainchild of Eugene Morozov, a tank with a crew of 2 people, which was supposed to prove that survival could be ensured without increasing the size of the machine. The idea seemed crazy. 2 tankers instead of 3, a commander gunner and a mechanic driver. No aimers, no loaders. The whole tank is 2 people in an isolated capsule and a set of automatic systems that do everything else. But the most interesting thing was not even that. Morozov proposed something that no one in Soviet tank building had done before. Hydro-pneumatic suspension. Instead of the usual torsion bars, a system that could change the tank's clearance right in battle. The tank could squat, reducing its silhouette to 1,600 millimeters, or, conversely, rise, increasing cross-country ability on rough terrain. The length of the machine was only 6,790 millimeters, more compact than many existing tanks. The suspension solved several problems at once. First, ride smoothness at high speeds. The tank could rush over rough terrain faster than a T-72 or T-80 without turning the crew into a mess from constant shaking. Second, changing the trim of the hull allowed increasing the gun aiming angles. The tank could lift its nose or lower its stern, giving the gunner more freedom when firing. Third, a low silhouette meant a lower probability of being detected and hit. The probability of being hit was reduced by 2 times compared to a conventional tank. But the hydro-pneumatic suspension was only the beginning. Morozov understood that in the event of a war with NATO, tanks would fight in conditions of the use of tactical nuclear weapons. Radioactive dust, contaminated terrain, the inability to exit the machine for refueling or loading ammunition. A conventional tank in such conditions became a dead piece of iron after a few hours of battle. Fuel ran out, shells ran out, and the crew faced a choice: go outside and receive a lethal dose of radiation or sit in the tank and wait for the enemy. The solution was radical. An armored refueling and armament machine on the same chassis as the tank itself, the BZZM, was supposed to accompany tanks in a column, overcome the same obstacles, pass through contaminated areas. On board, fuel and ammunition for 5 tanks, and most importantly, automatic docking without the crews exiting outside. 2 machines drive up to each other, docking devices connect, pumping begins. Full refueling of the tank, 2 minutes. Loading full ammunition, 5 minutes. The crews remain inside in the safety of their armored capsules. This was a revolution in logistics. Tank columns could fight for days without stopping for long refuelings. In the conditions of a nuclear war, when every minute in an open area meant an additional dose of radiation, such a system gave the Soviet tankers a chance to survive. NATO had nothing like it. American Abrams, British Challengers, they all required the crew to climb out for refueling. In a contaminated zone, this was a death sentence. The layout of the towpole was also unusual. The crew of 2 was placed in a capsule. Moreover, both crew members had a full set of controls. If the commander was incapacitated, the mechanic driver could take over fire control. If the mechanic driver died, the commander could drive the tank. System redundancy increased survivability. In front of the crew capsule was the fuel tank. Sounds strange, but it was additional protection. Diesel fuel does not explode from a shell hit, it simply leaks out. But the tank worked as an additional layer of armor, absorbing the energy of the shaped charge jet. The tank was isolated and had internal partitions to reduce fuel loss upon penetration. Even if a shell pierced the front armor and the fuel compartment, the crew remained alive. Ammunition was stored in a separate compartment, isolated from people by special partitions. If the shells detonated, the blast wave did not reach the crew. Each compartment of the tank was separated from the others, creating multi-layer protection. A shell had to pierce several partitions before reaching the people. The tank was supposed to receive the Active Protection System standard. 6 launchers, 3 on each side. The system detected incoming anti-tank missiles and shells, fired counter-munitions to meet them, destroying the threat on approach. In the 80s, this was science fiction. Active protection existed only in theory and on paper. But Morozov believed that in 10 years, technologies would allow creating a working system. And he was right. He just didn't live to see that moment. The suspension was protected by armor screens so that shrapnel and bullets would not damage the hydraulics. A 125mm gun with the possibility of upgrading to 130. An automatic loader of a new type, compact and reliable. Sights of the latest generation with a laser rangefinder. Everything most advanced that existed in the Soviet defense industry of the 80s. On paper, the Topol looked perfect. Compact, durable, deadly. 2 people controlled a machine that could withstand a whole platoon of NATO tanks. High-drop pneumatic suspension gave incredible mobility. The automatic refueling system allowed fighting in conditions of nuclear war. Isolated compartments guaranteed crew survival even if the armor was pierced. But in October 1984, generals from the Main Automotive Armored Directorate and the Main Rocket Artillery Directorate arrived in Kharkov. They looked at the Topol, listened to reports, studied the blueprints. And then General Litvinenko, head of the scientific committee of the Main Rocket Artillery Directorate, took out one diagram. It showed how much more effective the 152mm gun was compared to the 125mm. The difference was huge. Armor penetration, lethal action of the high-explosive fragmentation shell, effective fire range. By all parameters, 152mm were an order of magnitude more powerful. From that moment, the caliber of 152mm was adopted for future tanks of the USSR, and no one ever returned to this question. But for Topol, this meant a death sentence. The tank could not simply be taken and redesigned for such a powerful gun. And meanwhile, another project, Object 490A Buntar, was already being built in metal. Object 490A Buntar was the answer to the main problem of Topol. 2 crew members is too risky. Kharkov designers under the leadership of Shomin proposed an alternative layout. 3 people instead of 2, the mechanic driver in the hull on the left, next to him a fuel tank of 90 liters. Commander and gunner in a low-profile turret, placed one after another. But the main innovation was on the outside. The gun was mounted not inside the turret, but on its roof. External armament gave several advantages at once. First, the turret became lower. The tank's silhouette decreased. Second, there was an opportunity to increase the gun depression angle. 8 degrees down. By Soviet standards, this was a breakthrough. Ordinary tanks could lower the barrel by 5, at best 6 degrees. Buntar could shoot from steeper slopes, could more effectively use terrain irregularities for cover. Third, the turret became more spacious. The crew received more room, working conditions improved. But a price had to be paid for these advantages. The gun outside the turret meant that it was subjected to direct exposure to shrapnel, bullets, shaped charge jets. Any hit could damage the aiming mechanisms, the stabilization system, the barrel itself. A conventional tank gun is protected by the massive armor of the turret. Here, there was almost no protection. The developers counted on compensating for this with modular armor, add-on blocks that could be quickly replaced, but the problem remained. The armor of Buntar was revolutionary. 10 layers of metal and ceramics, 5 layers of steel, between them 4 layers of ceramic inserts. Combined protection provided reliable protection against armor-piercing subcaliber shells and shaped charge ammunition. But the main thing was the roof armor, unusually high, both on the hull and on the turret. This was protection against top-attack artillery fire. NATO was actively developing guided artillery shells that attacked tanks from above, where the armor is traditionally weak. Soviet designers took this threat into account. The roof of Buntar could withstand a hit from a high-explosive fragmentation shell or cluster munition. The installation of Dynamic Protection Contact 5 was assumed. Explosive blocks were to be attached to the front and sides, but the production of samples was closed before it reached this stage. There was no dynamic protection on the running mock-up, but there was a possibility to install it in the future. The design of the hull and turret provided for this. The armament consisted of a 125mm gun of increased power, 2 A66M. A variant with a 130mm gun was being developed, but it did not come to fruition. The mechanized ammunition rack occupied the right part of the fighting compartment. Shells were placed horizontally in 5 rows. The crew was separated from the ammunition by a partition. If the shells detonated, the blast wave did not reach the people. In the future, it was supposed to use shots with a charge of variable shape, abbreviated ZIF. A revolutionary idea. A charge that could change its configuration depending on the type of target and firing range. This allowed creating an automatic loader with maximum density of use of the tank's internal volume. More shells in the same space. But the technology was raw, required refinement. The fire control system was called Argus, a main computer connected to a radar, thermal imaging sight, and television cameras. 2 panoramic sights for the commander and gunner. The night thermal imaging sight was placed separately to the right of the automatic loader. The view was provided using fiber optic devices placed around the perimeter of the turret. Instead of traditional prism devices, fiber optics. This increased visibility and improved anti-radiation protection. The chassis was created based on the T-64, but with changes. 7 road wheels per side instead of 6. Shock absorbers on the 1st, 2nd, 6th, and 7th suspension nodes. Hydro-shock absorbers with a 2-stage characteristic, ensuring ride smoothness at high speeds. Tracks with a width of 580 millimeters to reduce specific ground pressure. Engine 6, TD3 with a power of 1,500 horsepower. On a tank weighing from 48 to 50 tons. This gave a specific power of about 30 horsepower per ton. Estimated speed on the highway, 75 kilometers per hour, on rough terrain, 55 kilometers per hour. By 1982, a full-size wooden mock-up was made to work out the layout. In 1984, they began to build the first running prototype. By 1985, 2 experimental prototypes were made, but neither of them could shoot. there was not enough time to fine-tune the weapon system. The gun stood, the loading mechanism was installed, but firing tests were not conducted. The second prototype was never completed. Readiness was less than 50%. After the decision on the caliber of 152 mm for Buntar, it was the end. The layout with the external gun could not simply be taken and redesigned for such a powerful gun. The recoil of the 152 mm gun is 3 times stronger than that of the 125 mm. Installing it outside the turret meant a risk of tearing off the mounts, damaging the aiming mechanisms. A complete reconfiguration was needed. Buntar turned into Object 477 Boxer, later renamed Mola, a completely new layout. Classic scheme with a crew of 3 people, gun inside the turret, extended chassis based on the T-64 with 8 road wheels. Many technologies transferred from Buntar: modular armor, fiber optic observation devices, hydraulic transmission, the concept of ammunition isolation, and Eugene Morozov continued to work on his project. Object 490, Topol also required redesigning for 152 mm, and Morozov decided not just to install a new gun, but to create a machine that the world had not yet seen. Morozov took the idea of Topol and took it to the point of absurdity. Object 490B, Belka, became the most radical tank project in the history of the Soviet Union. 4 tracks, 2 turrets, 2 engines, crew in the stern, everything else in front. 4 tracks gave phenomenal cross-country ability and survivability. Each track had 3 road wheels. The front and rear worked independently. The enemy had to destroy both tracks on one side to immobilize the tank. Blew up on a mine? The tank continues to move on the 3 remaining ones. Specific ground pressure became minimal. Belka could pass where other tanks got stuck. 2 engines gave power up to 2,000 horsepower and redundancy. One is disabled, the second continues to work. Each had its own onboard gearbox. A hydro-volumetric mechanical transmission distributed power between the 4 tracks. The armament consisted of 2 turrets. The front one carried a 152 mm gun, 2 A-73. Automatic loader with 2 horizontal conveyors, 32 unitary rounds, with a length of 1,400 mm. A fully automated system allowed firing without crew participation, and here began the main problem. The turret stood on a strongly inclined frontal armor of 68 degrees. When the turret turned back, the gun rested against the inclined plate and tilted up. Depression -5 degrees, elevation +10, but only in the range of plus or minus 45 degrees from the longitudinal axis. When turning back, a dead zone of about 120 degrees was formed. The tank could not shoot from the main gun to the stern. In urban combat, this is a death sentence. The enemy comes from the rear, and Belka is helpless. The developers tried to compensate for this with a second turret. Above the crew compartment was a small turret with a 30 mm grenade launcher, 360 degrees horizontally from -10 to +45 vertically. Against manpower and light equipment, it is suitable. Against tanks, it is useless. 2 machine guns, TKB, 666 caliber, 7.62 mm on the sides of the stern. Elevation angles 45 degrees. One can shoot at the upper floors of buildings. Ammunition load 1,500. But even this did not solve the dead zone problem. The protection was phenomenal. Equivalent to 2,000 mm against armor-piercing shells, 4,500 against shaped charges. Roof, 300 millimeters. But this was achieved not by composite armor, but by sequential barriers. 100 millimeters of steel, plus 500 millimeters at an angle. Fuel, engines, ammunition, multi-layer protection. The fire control system included modular television and thermal imaging sights in the armored mask, devices 1 PN-71, 1 PN-16 Argus, panoramic sight on the rear turret. View via video cameras on the hull. No prisms, only screens in the crew capsule. An interesting find, the gun barrel was used as an air intake pipe during underwater driving. Lift height 4,600 millimeters with elevation to the stern, 30 degrees. And then came the year 1991. The USSR was fallen apart. The economy in agony. There is no money for anything. The Kharkov Design Bureau was suffocating without funding. Projects were frozen one after another. On March 21, 1991, Eugene Morozov died. He was 59 years old. He managed to publish the last article in the journal Herald of Armored Technology, a description of the concept of the prospective tank of the 21st century. The article came out after his death in the 7th issue of the year 91. On December 26, 1991, the Council of Republics of the Supreme Soviet of the USSR adopted a declaration on the termination of the existence of the Soviet Union. The Kharkov Design Bureau ended up on the territory of independent Ukraine. Funding stopped completely. The world never saw the tank with 4 tracks. No one after the USSR tried to repeat this scheme because everyone understood what Morozov would have understood had he lived to see the tests. A brilliant layout with a fatal flaw remains just a flaw, beautiful, technological, ambitious, but a flaw. If you like this story about tanks that never fought, like and subscribe to the channel. Here we analyze the most absurd military equipment that failed precisely because its creators were too smart for their time or too stubborn or simply did not think about how it would work in real combat.